Hello, my name's Robin Vincent and welcome to Molten Modular. Today we're going to build an ambient patch. I mean, that's what modular's all about, isn't it, ultimately? I mean, okay, there's two camps, I guess. There's your noise and your grit and your glitch camp, and then there's your kind of ambient and chilled out crowd. Or is that very stereotypical? I don't know. I'm just making this up as I go. But ambient music is one of those things which I've always been into, I've always enjoyed, I have albums of the stuff out there, would you believe? All of it trying to soothe our souls with music. Well, last week I was involved in a contemplative event and I spent sort of the week, I think, working up an ambient patch that could fill what was essentially a cathedral. And what you heard there at the beginning was kind of what I did. Here it is again, look. Now, it's kind of beautifully self-perpetuating to the point at which I kind of left it running for about half an hour while we were doing other things, and it did its thing. In fact, at one point I sort of went to it as if to perform something, and I couldn't really find any knobs to turn or anything to do very much to improve upon what it was doing itself. In the end, I think I managed to patch in a drum, so I brought a kick in, which was quite nice, and then I attempted to bring in the basilius, and that didn't really go very well, but never mind. But what I would like to do in this video is share the experience of putting it together. So I'm going to break down this patch and just show you what I did, just to find out, just to share that knowledge. I mean, if you're new to my channel, then welcome. You're very, very welcome. But I'm not coming at this as some kind of expert teaching you how to do something. All I'm doing is doing what I do, my journey of making music and messing about with modular, and then I bring it to the camera and try to share it with people because people seem to find it interesting, and I enjoy sharing this stuff and talking about it and waving at the camera and things. So, hopefully this is a good symbiotic relationship where I do stuff, I then talk about it, and you watch it and enjoy it and go off and get inspired to do your own thing. That's ultimately what this is about. So in thinking about how do I then go through this patch to show you how it was done, the only way I can do that, I think, is by taking the whole thing apart and then doing it again. But in order to do that, I needed to find some way of recording what the heck this was, what it was doing. I mean, I can take a picture, sure, you can take a picture, and that's going to give you some idea, and you can potentially zoom into that picture, zoom out, and you can repatch it, perhaps. But I thought that maybe there's a better way of doing that. So I got out my Surface here. Ta-da! And I took a picture of my rig from Modular Grid, which is all my modules set out. And then I started drawing on it to see whether I can make those connections and make enough notes to allow me to take the whole patch apart and then put it back again. Because that would be awesome. I mean, it's a way of recording something fabulous that you did. I mean, I also did take a picture. I got a picture of it here, also for reference. So, and I took notes, look, notes and everything. I've never been this organized about anything in my life. I mean, there's no way that that's going to continue, that I'm going to be able to do that every time I do a patch. However, if I do come up with something interesting, I'm going to give that a go, because perhaps that's a way of relearning, of keeping hold of something so I can come back to it, so I don't have to keep learning the same thing over and over again. But before we do that, I wanted to do something else first. I wanted to attempt some kind of an approximation of a Krell patch. Now, what the heck is a Krell patch? It's one of those words that gets thrown around in modular quite a lot, and people talk about it and debate it and get into real deep electronics and synthesis about it. And I, at no point, are going to claim any ownership or knowledge of what this is about. But to share what I have gathered is that a Krell patch is a reflection of the music that was created for Forbidden Planet. Forbidden Planet is a sci-fi movie shot in 1956, which contains artifacts from an extinct race of, hyper-intelligent alien beings called the Krell. And underground on this planet, they discover this Krell machine, which is like the pinnacle of their technology, which can create physical thought out of mind, subconscious something or other. It doesn't really matter. Suffice to say that in the background to Forbidden Planet was this music, this kind of background industrial movement of sound that represented this Krell machine. And so a Krell Patch has come, I think, to sort of represent a self-perpetuating movement of continuously changing and modulating sound. And the first Krell Patch came from a guy, again, I think, called Todd Barton, who produced it on a Buchla. It's his work, really, that Krell Patches are based on. Since then, I think, if I seem uncertain, it's because, my research into this is very sporadic. And I don't want to get drawn into talking about that. I just kind of want to get on with it. So, to summarize then, a Krell Patch, as far as I can gather, is kind of an ambient background environmental noise of moving textures and sound that is created kind of very simply using functions and logic. And that's what I started with when I was looking at building this ambient patch. Now, I stumbled upon a conversation about Krell Patches on Facebook, and within it, a very helpful gentleman called Daniel Kramer posted his little Krell Patch just using a maths and some modulation. And I thought, fabulous, I'll give that a go. And so I did. And so that's what we're going to do. And so with a certain amount of sadness and intrepidation, I'm going to pull this apart. And in the hope that we will put it together again later, shortly, after we've had this quick Krell tie version. So that's fun. Right, a clean sheet. Now, I'm sure there's lots of people who have a lot of things to say about Krell Patches, and that's cool. Feel free to educate me in the comments. That's awesome, because I've just had a bit of a stab at this. I found a thing on it. I looked into it a tiny bit, and I tried it out and saw what happened. And that's what I wanted to share just very quickly, because I think it's slightly fascinating how you can go to as much depth as you like, which is cool. But this is Krell light, if you like. This is Krell for dummies or idiots like myself. So following Daniel Kramer's instructions then, what it says is that we use Maths Channel 4 in cycle mode. So put cycle on, Channel 4. And we patch that into a VCA. Channel 4, VCA. I mean, we put it into the CV input on a VCA. Presumably we're going to use an oscillator at some point to actually make noise. Now the next bit is really interesting, and this is where we start learning. It says you take the end of cycle output of maths. Now that had me stroking my beard thinking, I wonder what that is. And then, having a look around, oh, here, EOC. There's a socket here that says EOC, end of cycle. That sounds likely. So presumably this sends some kind of pulse when it gets to the end of the envelope cycle. How interesting. You take that and you plug it into the trigger input on a sample and hold circuit. Sample and hold. Right, this is one of those modular synthesis things where it shows how little you actually know about anything. I mean, sample and hold to me has essentially been some kind of randomizer thing. I used to have one on my DX100, which was the first synthesizer that I owned, and in part of your creating patches or programs on that, you could add sample and hold to something, and it would go, it would give you that sort of noise. So I assumed that's just kind of what it was, like a random generating stepped kind of thing. And when you use a regular normal synthesizer and you have sample and hold, all you do is direct that to things. You don't actually have to create it. You don't have to sample anything or hold anything, because that's all built into the structure of the synthesizer. With modular synthesis, you have to make that stuff happen. You have to do it yourself. So do I even have a sample and hold circuit to start with? No, I don't. However, I do have a Disting 4 up here from Expert Sleepers, and that has a sample and hold algorithm. Awesome, let's use that. So I pulled up the manual for the Disting, because I do read manuals when I need to understand anything that the Disting does. The manual is very important. However, it's not always immediately helpful. what it says for sample and hold is that A equals X when Y exceeds 1 volt. Now B equals noise, plus or minus 8 volts, and Z is the slew rate. Got all that? No. No, I didn't either. But essentially, what sample and hold is about is that you take a source of noise. Noise is, if you like, is every random number that there ever was stuck into a thing. It's noise, lots of noise going on, lots of numbers. What sample and hold does is that it takes a sample of that noise to achieve a single value, and then it holds that for a certain space. And then it's noise again. And then it samples, holds, noise. So it's a way of creating random values because you have every value in the world in the noise, and it goes, I'll pick that one. And that's the one you're going to have. And then it's noise again, and it picks another one. And then that's going to be a different value. So you get this continuously varying signal. That, I think, correct me if I'm wrong by all means, is what sample and hold is about. So you need a noise source, you need a trigger to tell it when to sample, and then I guess how long to sample for, or I guess till the next trigger. Yeah, that sounds about right. Let me see if I can demonstrate that very quickly. I need an out, go into my out so we can hear something. Let's take the output from my black VCO, stick that into the Jove filter, take the output of that into here. So what I'm going to do is I'm going to jam sample and hold into this thing here, yeah? Because that will be really, really obvious then, yeah? So let's focus on the disting then. So first of all, it needs a noise. Now, the disting algorithm creates noise out of B. So this is generating white noise already. So I can take that and plug it back into itself. Excellent. Now the input, I believe, is X. So I put that into there. That's a connection made. Now the output, the random voltages, are, I think, going to come out of A. Let's go with that. So A is going to go into CV input on the Jove. Now if I press the button on the disting, it does the sample, and that is that familiar sample and hold sound. Now if I can send it a clock from something, then it will do it. And if I turn up Z, it then does the slew business. The slew business is like portamento, moving between two different things. So it becomes a movement rather than a step. So there you are. I bet you weren't expecting to learn all about sample and hold today. So that's exciting. Bit of our diversion. Back to our Krell Patch, that we haven't really got anywhere with yet. So what I was doing, I was taking the end of cycle it says, into the trigger in. Now the trigger in was coming from the Batumi here, so I take that one out, put that into the trigger input. So that is now going to trigger another value on every cycle of the maths. Groovy. Now in order to complete this little circuit, because Krell patches are surprisingly simple, I just need to take this value out of here, which I've been putting into the filter, and put it into 1 volt per octave on an oscillator. So let me stick it into the black VCO and plug it in to our VCA, like so. Got it going through a filter because I'm bound to want to use that at some point. Now, do you hear that? So that's already making spooky 50s sci-fi music, don't you think? So what I've got here is I've got the envelope on math cycling through. I've got the end of cycle triggering a sample and hold. That sample and hold is taking a random value and sticking it into the pitch input on the oscillator. So I'm getting these different random pitches, as you can hear. Now we're not done. There's a bit more genius involved in this, and that's to do with modulating that envelope. It's well spooky. So you've got to stick an LFO into the rise and another one into the fall. Now there's a lot you can do to tweak this. I mean, first of all, playing with the rise and fall knobs is going to make a lot of difference. The other thing is trimming the LFOs just by plugging them through my trim. And then also changing the speed of the LFOs. Now, of course, you can endlessly play with it and toy with it. I mean, you can even put it through a quantizer so that it's not quite so random, or you could say it's more musical. Anyway, endlessly fascinating, I'm sure. So that was a very basic Krell patch based on some information I got off Facebook from a guy called Daniel Kramer that I've just jammed in here, and it creates this wonderful 50s sci-fi creepy crazy music and gives you lots of things to play with and toy with. And that kind of kick-started me into this idea of creating an ambient patch and what it was I wanted it to do. I wanted it to self-replicate. I wanted it to play itself far more than me having to do things with it, or for me to create a tune that it needed to follow. I just wanted it to evolve and to change, and to vary in pitch and to vary in timing. That was the plan. That was the starting point. Let's go back to a blank canvas and see if I can talk you through what I did. Right, the basis of this ambient patch I knew was going to be the 2HP Pluck, which I recently acquired, which is fabulous. I've done another couple of videos on just noises from it, stuff going through it, and it's great. It's great because it has this initial pluck sound, but then it has 4-voice polyphony, so you've got these noises and sounds going on underneath, which you'll hear in a minute. It's just a lovely little thing. So I wanted to use that, and I wanted to use a Turing machine to create the notes. I'll be running the Turing machine through the microscale, the IntelliJ microscale I've got here. So all the action is going to happen down in these 3 modules here to start with. But then, because I have learned quite a bit about this business now, it's going to get more complicated kind of quickly, because I've started getting into the idea of mixing CVs and taking charge of stuff. Rather than stumbling on, I can now find myself doing things on purpose, which is an interesting feeling. So to start with, I needed a clock. For the clock, I'm using the random rhythm because I get all sorts of clocks out of there, and I wanted something really slow, and that seemed like a good place to start. So my first little patch was the sequencer out of the random rhythm into the clock on the Turing machine. Turing machine needs something to get it going, and that's what it is. With the sequencer out on the random rhythm, it means that I'm using a combination of different ticks that I can change. So it's not going to give it a standard steady clock. It's going to give it a clock with some variation, because this fires every time one of these 4 sliders here fires. I've got quarter notes, eighth notes, 16 notes, and triplets, and I can set that up to be as complex as I like, and that's going to be feeding the Turing. But I want it to be slow, so I don't want it to be too busy. I just want it to have a sense that it's changing and varying. I can then take the output of the Turing and plug it into the U scale, because I want the U scale to conform it to musical notes rather than it just being random voltages. But I want to be cleverer than that. I want to add a little bit of modulation to those notes, so it's not just kicking out the same handful of notes all the time, you know, in randomly within a thing. I wanted to move them up and move them down, have them constantly moving, and to do that I needed to add a little bit of CV to it. So to show you what I mean, I'm going to plug it into the STO over here, which I'm just using as an example for the moment. Let's just plug that in, so I've got something going through. So there, first of all, the random notes from the Turing. I then want to plug that into my microscale so that I get notes. Might have to add some notes. But rather than just that, I wanted to mix some CV with the output of that in order to give it some variation. So I'm going to take the output of the Turing machine, plug it into a mixer up here, take output 3 from our friend the mat, because I now know that creates CV. I'm going to plug it into the second channel on the mixer. Then I'm going to bring back the output of those two channels back into the U scale. And now what I get on knob number 3 here is the ability to change the pitch range of the Turing. Now you do have a scale knob on the Turing itself, which does a similar job, but I wanted to get some modulation over that, which you can't do on the Turing machine itself. Whereas over here, I can take a slow moving thing from the Batumi, plug it into number 3, and listen to that. So I didn't want that to be quite so severe, and so I ran it through a trim. So let's take the out of the Batumi, stick that into in, take the out of that, back in. So that's quite nice. I've got random notes coming from the Turing, which are being tamed by the microscale. At the same time, I'm introducing some CV to vary the range of notes up and down. And so it's creating this sort of interesting variation where it's not just going scale up and scale down, it's sort of messing about as it goes up and down, which is exactly what I'm after, messing about. Now that's great, that's going through the STO, which is something that I wanted, but I actually want it going through the Pluck. So let's do that. Let's take that out of there, stick that into the 1 volt proctive on the Pluck. Let's take the Pluck's output, put that into my VCA. Now what you need in order to trigger the Pluck is a trigger. Trigger's at the top. You can sort of do it by tapping the cable. Sort of. But isn't that lovely how those notes are moving underneath? You've got your initial twang. I'm not sure how I get this to work. It's just a lovely thing. So I need a trigger for it. Now initially I used, I think, the pulse on the Turing. and that's quite good, but it's just a bit too often. I just want an occasional twang rather than this one going on all the time. So for this, I decided to employ the varigate, just using the gate mode. So I can set up some probable gates on one of the channels of this, running at a slow speed, and that could trigger the pluck. So to give the varigate a clock, I could have taken it from a clock divider up here, but I didn't. One reason or another, I took another clock out of the random rhythm because the random rhythm is so bleeding useful. I took out the quarter note over here, put that into the clock in. So that gives a nice slow clock to the varigate. And then on channel 2 here, I just set up a bunch of gates to give me probable triggers. There we go, trigger, 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 trigger. If I move those further down, they become less likely. I'd also put repeat onto a couple of them as well, which occasionally happens. But it's nice, it means I've got this very slow, occasional pluck with these wonderful notes happening underneath, being controlled by the Turing. I mean, that on its own is pretty beautiful. Doesn't always hit the perfect note though, but that's okay. I don't mind the imperfections creeping in. So to compete with this, I added in the STO. And to do that, I take the second output here and plug that into 1 volt per octave on the STO. Now that's not quite as lovely. Now the out A and out B on the microscale could be set to an interval, so you can have them running 2 different notes. Now I did sort of intend to do that, but I wasn't entirely sure whether that worked or not. And in the end, I just kind of tuned the 2 oscillators until it sounded about right. It's sounding okay. It's sounding a little, potentially a little bit off at the moment, maybe. The other thing is that the STO is far too prevalent, and so what I want to do is gate or envelope the STO to make that less persistent and a little bit more occasional. So I took the other side of the maths and set that up as an envelope. I'm going to take a quarter note out of there, plug that in to trigger my envelope, take the sum envelope out and apply it to the ST0. So that adds something more to it, I think. Then, of course, you really want to modulate something. And then you want to modulate something on that maths just to give it a bit more variation. So I'll take something out of my patchouli again and I'll plug that into the full. And just to complete this little ensemble, I thought I would put the pluck through a delay. So rather than going into the VCA, I'll stick it into a delay there, and then patch it into a little mixer over on this side. So there you go, there's sort of the main guts of it, I suppose, the main engine that's going on. And it's pretty nice. I mean, the tune, which sounds, I don't know, somehow Celtic, something like that, is because of the notes I've chosen on the U scale. If I can choose different notes, it will come up with a different feel. But that's not all. No. I then did some other things too. I put the STO through my Jove filter. Now there's not a whole lot for the filter to do, but I wanted to apply a little bit just to give it a bit more of a change when it came in. And to do that, I took some sample and hold out of the Batumi because I'd upgraded the firmware on the Batumi, and that gives you a sample and hold style, flavor, random output on the assignable one here. So none of this messing about with trying to sample noise and trigger and that kind of thing. It just gives you a load straight out of here, which is ideal. And that's just going to add a little bit of flavor, add a little bit more flavor to that sound. Now that's pretty nice. It's pretty nice. I'm so pleased. I have to say, I'm so pleased that I'm able to recreate that patch because I was really enjoying using it. And I have other things to do. I need to get on, need to make some more music. But that particular patch I thought is probably the best thing I've come up with. I mean, I've come up with some crazy stuff and some fantastic stuff, I'm sure. But this, it's good because it came out of my head. I didn't just kind of stumble, oh, maybe I should put this here and put that there. It came from a place where I'm intending to do something. And I put things in different places. I mixed CVs together. I thought about the modulation and what it was that I was attempting to do with that. And I sort of solved problems as I went, as in I wanted to, how do I get to, oh, I can do that. Or I can put those two things together over here. So the last challenge was, well, I still have other oscillators in this system. Maybe I could add kind of a drone underneath. I mean, that would be pretty awesome. I mean, for that, I often put my Mother 32 over here. I put that into drone duty because it has this keyboard and you can very easily change notes on it without having to put something else CV-wise into it to do that. But because I was taking this out on the road to an event, I wanted to have it all in the one box. So that meant using something here, and ideally for a nice drone, the black VCO, I think, is the one. But I wasn't happy just to have a single noise. I wanted it to change. Of course I wanted it to change. And that meant employing the clock divider and sequential switch. Those boys, those are the ones that sorts this kind of thing out. So let me just go through that to add in a changing drone underneath the ambient melodies. So first and foremost, I need the sound. So let's take the output from the expander, plug that in here. And there it is. Question, of course, is it in tune? Kinda. Something like that isn't bad. I'm liking the raspiness of it, I have to say. So how on earth am I going to change it? Well, I need to send it some CV in order to change the pitch. Now I can do that obviously sending it a sequence, but I only want it to change a little bit. So if I send it some CV from channel 2 on the maths. Oh! 1, 2. So there it is at its original. And then I just want to put it up like a fifth or an octave or something. So I just need to add it. A little bit of voltage into that input. And I can use a sequential switch brilliantly in order to do that. Now, gonna remember how I worked that out. Yes. So first of all, the output of the sequential switch, which is, this is your trigger in, and then the output is here. Or it can be an input, but the output that I want to generate, I want to send to there. The next thing a sequential switch needs, it needs a clock. It needs to be clocked somewhere. So I took the clock from something else, from here, the thing that was triggering the maths. I took that clock and I molted it over here. Look at that, using a molt. I could then take one part of that, stick it into the sequential switch. I also need to take another part, put that back into the maths over there to trigger that. Now, as you can see, the sequential switch is stepping through these different steps every time it gets a clock. Bum, 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 bum. If I stick it onto 2 steps, just to make it easier to demonstrate, and then we'll put it back to 4 steps in a minute. So at the moment, the output is getting nothing, and then it gets nothing. So it's just stuck on what it is. So what we need to do is take the output of channel 2, plug it in to the second one of those, and it will now change, depending on what I've set it to. See, that's about right. But the timing is all off. I don't want it to be changing that fast. I want it to be changing in 4 steps. So I can turn 4 steps on, put that down to the bottom. But I still don't want it to be changing as quickly as it is. So I will put the clock into my clock divider and then take a really slower version of that to the clock on the sequential switch. And now that's going to move through there far slower. And obviously the length of switch number 4 will be longer. So there's that change. And back again. But of course, it's no good just having that by itself. We need to run it through a filter. So I'll take the output through my polyvox over here. And then I could give that a bit of random. Well, I'm not entirely sure that's appropriate. Some strange notes in there sometimes, but I'm not entirely sure that that's appropriate, so I'm going to just give it a good old-fashioned sine wave. So there you are. I mean, with a bit of of fiddling and tweaking and messing about, changing around of things, because I now have a lot that I could be playing with. But it's pretty happy doing its own thing, beautifully happy doing its own thing. So there you go. I hope that's helpful or useful, and now I'm going to pull this apart and do something else. But before I do that, I'll just let it running at the end of this video, and I'll take the camera through it so that you can have a proper look, perhaps, at all the connections. If that's interesting, I don't know. Who knows? Let's just stick it on the end and see what happens. So that'll do, and if you have any questions, then do throw them into the comments or contact me through any other form of social media. I'm always happy for a bit of a chat. Or if you're feeling spectacularly daring, then do check out my Patreon account and become a patron of Molten Modular. How awesome would that be? Coming next is my long-awaited review of the Vermona Random Rhythm. I really have got to grips with it now, so I'm pretty sure that the review is imminent. And in the meantime, go and make some tunes.